Hi, it's time for another math easy solution. Turn to discuss further into applications of integrals and now look at further into probability and look at example 1 of the normal distributions video series. Basically, I'm going to go over this example which states the intelligence quotient, or otherwise known as IQ. IQ scores are distributed normally with mean of 100 and standard deviation of 15, and the probability density function is shown in the graph below. And again, you might be familiar with IQ scores, you might have even taken an IQ test, etc. Now later in this video I'll go over a brief history on the intelligence quotient or IQ test. So basically, if this is probability density function, y equals f of x, then let's zoom in. So then we're given that the mean or average is 100. So we'll write that mu equals 100, as I explained in my earlier videos. For mean, you usually write by Greek symbol mu. And then the standard deviation is 15. So standard deviation 15, again, remember it's a measure of how spread out this probability density function is. And if it's 15, so 100 minus 15, that's just going to be 85. So somewhere here, let's go with 85. And then 100 plus 15, just to graph out how it looks. So it would be something like this. So then from here to here is one standard deviation of 15, and also from here to here, so 115 up to there. So that's here, and this one right there. So now part A of this example states what percentage of the population has an IQ score between 85 and 115, and part B is population that has an IQ above 140 if using this probability density function. So let's look at part A. So recall the probability density function for a normal distribution was basically f of x is equal to 1 over, this is going to be sigma, standard deviation, 2 pi, the square root of 2 pi times e to the power of negative x minus mu, which is the average or mean, divided by 2 sigma squared. So in our case we have sigma equals 215 and our mu, this equals to 100. So thus the probability is going to be, so again the probability for first one where we have a score between 85 less than equal to x, that's our variable, greater than, then it's going to be less than, where x is less than equal to 115. So between 85 and 115, this equals to, like I explained in my earlier videos, is basically the area underneath this curve. So it's, and again, this is one standard deviation difference from the mean. So we're looking at this area across for part A. I'll write that down. So part A is area across this. So that's part A. So this area, again, that's just going to be equal to, like I explained in my earlier video, just the integral of the probability density function. So from 85 up to 115, and now we have 1 over, again, write this down, this is going to be 15, because that's our sigma, square root 2 pi, and then we have e to the power of negative x minus 100 squared divided by 2 sigma squared, which is 2 to 15 squared, 2 times 15 squared. And then put the dx across like that to complete the integral. Now this integral is not straightforward to solve, and in fact, if you recall from my earlier video titled "Can we integrate all continuous functions?" you can see that in the video link below. The function y equals e to the x squared, or this one is just a variation of it. This is, again, this involves x squared like that, e to the x squared. This doesn't have an elementary antiderivative. Again, make sure to read more on that in my earlier video. So we don't evaluate, or we can't, this is a C, so we can't evaluate this integral exactly. So there's no way of actually solving this just exactly as we would regular integrals, but instead we would have to calculate it numerically using a calculator or manually using the midpoint rule or Simpson's rule approximation methods, which I went over in my earlier video, to estimate the integral. And in fact, these calculators or anything online or computers, these pretty much use variations of these midpoint rule or Simpson's rule or other approximation methods. And in fact, I'm just going to pull up a calculator right here. It's just online. This is just a random website. So in our case, we want to go, let's say the mean is 100. Standard deviation is 1.5, so it's normal distribution calculator. And we want between, so we want between 85 and 115. So recalculate. So this area underneath here is 0.6827, or I'll just write this down as this is 85 less than x less than 115, and this is roughly equal to, this is going to be I'll just go round up to 0.68. So I'll just round up 0.68, and then this equals 2. Well, if we times it by 100 to get the percentage, so 68%. So that is our answer. I'll just circle this whole thing. Yeah, so thus basically about 68% of the population has an IQ between 85 and 115. That is within one standard deviation of the mean. So again, part A is specifically to see what the percentage of the population was between one standard deviation. So that's, again, standard deviation is 15, so 85 to 115, and about 68% of the people you would fall between 85 and 115 of IQ scores. So now let's look at part B. What percentage of the population has an IQ above 140? So if we were to write this out, B, this is going to be probability of x is greater than 140. So again, this equals to just the area of the graph past 140. So like something like this. So that is our part B. So all the way to the right. As you can see, we expect it to be very, very, very small. So this is going to be equal to, well, again, the area underneath the curve. So 140 all the way to infinity, because it keeps going all the way to the right. So 1 over 1/5, this is 15 times square root 2 pi, and then, oops, this is e to the power of x minus 100 squared, all the way divided by, this is, let's see what there was, again, 2 times sigma squared, so 215 squared dx. And again, we can't solve this directly, but we could just estimate it using approximation, and in this case, let's just pull it out. So this one has it above 140. So above 140, as you can see, 0.0038. So this roughly equals 2.0038, and now times this by 100 to get a percentage. We just move this to the right twice. We get 0.38%. So barely anyone has that high of an IQ. Yeah, so in other words, basically roughly 0.4, just round that up again, percent of the population has an IQ over 140. And now I just want to go over a brief history lesson on the IQ score or the IQ test, just because I found it pretty interesting. Basically, the term intelligence quotient or IQ was coined, it was first coined by German psychologist and philosopher William Stern for a scoring method for intelligence tests he advocated in his 1912 book. And currently the mean and median is defined as IQ of 100, and each standard deviation up or down is defined as 15 IQ points. But this was not always so historically. So again, the example I used is what the current time, I think it's 2016, or this textbook was 2015. But yeah, so pretty much the modern time, this is what we use for IQ tests. And IQ scores, yeah, and it's the same as this example. So when IQ scores have been shown to be associated with such factors as health, mortality, death rates, parental social status, and to a significant degree, biological parental IQ. So if you have a high IQ, it's likely your parents had a high IQ, but But the problem with this is, while the inheritance of IQ has been investigated for almost a century, the significance and mechanisms of inheritance are widely debated because, well, if you are from a richer background, you're more access to to education, and so that obviously will increase your IQ. Yeah, so it doesn't necessarily mean you're just born smarter than others, necessarily. So anyways, IQ scores are also used for educational placement, assessment of intellectual disability, and also job applications. And IQ scores for many populations have actually been rising at an average rate of about 3 IQ points per decade since the 20th century. And this is called the Flynn effect. Maybe I'll go over that in later videos, or just read up on that on your own. And IQ tests are actually aimed to test a person's cognitive abilities, such as memory, attention, and speed. As opposed to this, standardized tests, on the other hand, focus more on knowledge of a specific topic at hand. Thus, even if students were to improve their test scores in, let's say, a math, science, standardized tests, they don't necessarily improve their IQ scores as well. This is more about how your brain thinks as opposed to what you actually know. And yeah, an example, just an example of one type of IQ test question is based on Raven's progressive matrices, which is shown below here. I'll go over this in a bit. Whoops. And yeah, these matrices were developed by John C. Raven in 1936, or were first developed. And the concept is basically to find the missing element that completes the pattern. So let's just go over this quick example here. So you can see this is a square with 4 squares inside. This is shaded here, this is shaded there, this is shaded there. Now we have a circle. So again, this is the same pattern, top left, top right, and then bottom right. Now we have to fill it in with this one over here. And well, the trick for this question is, well, think about this as a square that's rotated. So in this case here, if we were to rotate this, we would get this exact shape. And again, same thing here. If we rotate this, we get this one over here. And then rotate this again. Whoops. Yeah, let's rotate this one more time. So if we rotate this one, we should get the corresponding shape, which would be slightly rotated. So it would look something like this. Let me just draw this square. So then again, we're filling it in, and this one's rotated, so it should be over here. Just think about it as a rotated square instead of a diamond. So this is how that looks like. Let's shade it a bit more. So anyways, that's one example of the type of questions you might see on IQ tests. And again, about 5% of the population have scores above 125. About 5% have scores below, and then 2/3 are within 1 standard deviation, or 68% between 85 and 115. And although IQ is the most widely used method of measuring intelligence, there are still many criticisms and fallbacks, such as it neglects some areas of intelligence, such as creativity or social intelligence. And intelligence is a very abstract concept, so defining it as a single number is oversimplification. And also, the results of IQ tests have been often assessed more so for political reasons rather than simply scientific reasons. Yeah, so if you wanted to implement some sort of rule to target disaffected or disenfranchised minority groups, you could use the IQ test or politicians have used that, or other people have used it for their own purposes, as opposed to just simply scientific reasons. Because, like I said before, IQ, it's also, again, dependent if you are from a well-off background where you are more access to education and even just basic living needs. And also, IQ classifications such as superior or average vary with different publishers of whatever tests. Yes, some of them are just put labels to that. But anyway, so yeah, so I would recommend testing your IQ on anything online or whatever you can find wherever you live. But again, put that into perspective that it doesn't mean you are this number or whatnot, or that your intelligence is a specific target, and that there's nothing you can do about it. Anyways, that's all for today. If you learned from this pretty interesting video, this example on probability, as well as this IQ test, and hopefully you enjoyed that brief lesson as well. Anyways, that's all for today. Hopefully you learned, and like always, stay tuned for another math easy solution.